Hi, we are team number 4, and we are going to present permeable reactive barrier principle and application. My name is Oscar Guzmán González. My friends are Juan Ricardo Urrutia Guzmán, Francisco Hernández Mesta, Abelino Montoya Montoya, Luis Félix Martínez Oyervides. What are permeable reactive barriers? Well, PRBs are in situ treatment zones placed underground to clean contaminated groundwater. They are constructed across the flow path of groundwater. As water flows through the PRB, contaminants are removed or degraded. They are permeable, meaning water flows through them freely, unlike impermeable barriers.
Okay, so today I'll be explaining the principle of operation. PRBs are a passive treatment system which don't need pumps or external energy. They're placed underground, directly in the bed of the contaminated water. As water flows through the barrier, it interacts with reactive materials that remove or neutralize pollutants. These interactions involve different mechanisms like redox reactions, for example, using zero-valent iron to transform or immobilize contaminants, precipitation, where contaminants from solids and settle out, absorption, where pollutants sticks to the surface of materials, and sometimes even biodegradation helped by microbes. Okay. Now regarding to the reactive materials, different contaminants require different strategies. The most common one is zero-valent iron, which works well on chlorinated solvents and heavy metals. Activated carbon is used for pollutants because it's excellent at absorption. Peat or compost helps microbial degradation, ideal for hydrocarbons and nitrates. And limestone is used when the water is acidic or when metal removal is needed. So overall, the barrier acts like a filter, but instead of just trapping contaminants, it actively reacts with them to clean up the groundwater as it flows through.
In applications, uh, we used to treat in chlorinated solvents, in heavy metals, in nitrates and phosphates, in petroleum hydrocarbons, and is installed at industrial sites, landfills, military bases, and agricultural runoff zones. I can tell you about applications. Uh, yeah, I can tell you that in applications we have different types of contaminants treated, uh, like chlorinated solvents, heavy metals, petroleum, etc. Also, we have common installation sites, like we say, in industrial zone, landfills, military bases, and brownfield and superfund sites. We also have design and engineering flexibility, vertically to intercept horizontal groundwater flow, horizontally for shallow contaminants, and funnel and gate systems. And
Now I'm going to talk about the advantages and limitations of permeable reactive barriers. First, some of the advantages is that it's a passive treatment of contaminated water, groundwater, sorry, uh, in situ remediation of pollutants, a relatively low maintenance requirement, long-term solution for groundwater contamination. Also, I'm going to add something about the situ remediation of pollutants. That is an situ treatment zone of reactive material placed in the path of a contaminated groundwater plume as the groundwater flows passively through the barrier under natural hydraulic gradients. Contaminants are removed via physical, chemical, or biological reaction. Some of the common reactive materials included in this process are zero valent iron, that is for chlorinated solvent and metals. Also activated carbon, that is for organic compounds, and also limestone or zeolites, that is for acidic or metal laden waters. Also, some of the limitations in this topic is that requires accurate placement. And also, there is, we can say, a disadvantage is that may clog over time, and also is not suitable for all contaminants. And last is the challenging in heterogeneous aquifers.
When to use permeable reactive barriers. We use PRBs when there is a clear area of contaminated groundwater on, and we know the direction in where the water flows. They work best when the contaminants can be treated by reactive materials like chlorinated solvents, heavy metals, or nitrates. They are a good option if we want to clear the groundwater without having to pump in or use energy, especially in places when it's hard to build treatment plants on the surface. PRBs are also useful when we are looking for a long-term solution and a solution in which we don't need a lot of maintenance. Mm, Well, in conclusion, permeable reactive barriers offers a sustainable and passive solution for a groundwater remediation by using reactive materials placed directly in the path of the contaminant flow. They effectively treat polluted without the need for active pumping or energy, although they require careful design and have some limitations, such as high installation costs and maintenance of the reactive medium. PRBs remain a cost-effective and environmentally friendly option for long-term sites cleanup. Their success depends on proper site state assessment, material selection, um, and ongoing monitoring. This is all. Thank you for your attention.